Okay, the recording has started. So we were going through the list module in OCaml.org docs, and we finished up with the partition example, this one. So we are going to now look at the association list. Welcome, Sabine. I'm just starting the stream, and we're planning to finish the list module today. So let's continue looking at some of the list functions available in this module. So let me clear the screen. So for smaller list of pairs, there are useful list functions, but for generally for dictionaries, you want to use map or hash table modules, right? These ones. We could go over those modules in a different session. So what does the list.associate function do? So as always, let's first understand the definition. So it takes a type A and a tuple list and returns a B. So basically it returns the tuples B association for a given A, right? So let's try this example here, which says find me the association for 4 in this list of tuples. Okay, so we have 3 and the string 3, and then we have 1 and the string 1, and then we have 4 and the string 4, right? Let's run this. So it returns the string 4, which is the corresponding association for the integer 4. So there's also the list.member association function. Let's see the definition first. So when you're encountering new functions, it's nice to see the definition first so you understand what's the usage. So again, here it basically returns the bool instead of the actual value for a specific member in a tuple list. So let's try the same example here. List.mem associate 4 3 3 1 1, and then 4 4. Right. Let's clear this and run this, and then of course it returns the result true, right? So this is an example for the list association and list member association functions, right? So you can also make a list of pairs from a pair of lists, or a pair of list from a list of pairs. So let's see the examples for the split and combine functions here. Let me clear this. Right. So what does the list.split function do? So it takes a tuple list, right, and splits it up into individual lists, right? So it makes a tuple from a tuple list. So let's do an example here. So if I say list.split of 3 and 3 and 1 1 and then 4 4, close the semicolon. Let's clear this and run it again. So you give you a tuple with a pair of lists, right? 3 1 4 and the strings 3 1 4. Okay, so you can do the other way around, where you combine a pair of lists into a tuple list, right? 3 1 4, this is one list, and we have the second list, four, right. We will also check the definition of list dot combine, right. So, it takes a list, A list, a B list, and creates a new tuple list, right. So, we have takes a pair of lists and combines them into a list of pairs. Okay, that is what this example says. Nice. Let us move on to sorting list. So, the compare function can be used to compare any two values of the same type, right. So, let us see what the definition of compare is. So, it takes type A and another element of type A and returns an int. So, how do we actually use this? Let us see some examples. So, let us say I do compare of 3, 5. What does it return? It gives -1. So, 3 is less than 5, so it returns -1. What if I give 5 and 3? It gives +1. So, 5 is greater than 3, it gives +1, and if I give the same value for comparison, it returns 0. Okay, so, this is the compare function. So, let us use it in this example of sort. So, sort basically, can clear this, list dot sort, it takes a function, the criteria for comparing, and so we give this list 1, 4, 6, 4, 1, right. Let us run it, and it sorts it in ascending order, right. But this is not just for integer lists, we can also sort for strings, because these are like polymorphic functions, right. So, if I say Reynolds, Smith and Barnes, I made a typo here, let's fix that, and let us clear it and let us run it again. So, it is the sorted list now. Now, there is a function called fun.flip, which basically can reverse the functionality. So, what it does is it takes a function, it takes A, B and C parameters and then returns B, A, C. So, it does the reverse of it. So, we can actually reverse the comparison here in the list.sort usage. So, I can just call fun.flip of compare. So, instead of sorting in ascending order, it will sort in descending order. Right, let us run this. So, it is now 6, 4, 4, 1, 1, right. It is an example of fun.flip. Alright, we can also do the comparison sorting in a list of tuples. So, let us say we do 1, 3, 1, 2, and then 2, 3, and then 2, 2. Let me close this. So, now we are sorting on the first element, right, and if it matches, we are sorting on the second element, right, 2 and 3. So, 2, 2 is first, and then 2 and 3 on the second element in ascending order. So, we can also similarly use sort. We can actually use a specific function for comparison, A, B. I am just going to call first of A and first of B. So, I am instead of comparing both the A's and then the B's, I am doing A and B comparison, and let us say we use the same list 1, 2, 2, 3 and 2, 2, and we run this. We now get comparison of first A of A and first of B. So, we get 1, 3, 2, 2, 3 and 2, 2. We have seen an example of folds. So this is two important functions, the fold left and the fold right. So let's start with the fold left, and I'll explain you how the actual computation happens. So let's see what is the definition of fold left. So it takes a function and then a initial value or accumulator and then a B list and returns the accumulator. Okay, that's the fold operation. So let's see an example here. List dot fold left of 0, 1, 2, 3. I'm just going to run it and then I'll explain to you what is actually happening here, right? So what we're doing is we have this accumulator and it produces the sum 0 plus 1. It adds the result back to this accumulator 1. For the next subsequent computation, it becomes plus 1 and 2, so it becomes 3. And for the last computation, it becomes plus 3 and 3, and hence the result is 6. So how does this actually look like, right? So basically, it's like doing plus 0, 1, okay. Result is 1. To this computation, we are doing plus 2. The result is again copied to the accumulator, and for the final computation, we are doing plus of that result to 3. Okay, this is exactly what is happening. So you sort of see the parenthesis on the left, right? You're sort of folding from the left. That's why it's called fold left. Okay. So then another example here where they use the max function. So what does the max function do? So given type A and another type A, it actually returns the maximum of the two values. So let's use that in the list.fold left example. You say max of minint is the default accumulator value, so using the defined one there to and the list. So it compares each element in the list with minint or the element in subsequent iteration and returns the maximum value, right. So of course it returns 6, which is the maximum element in the list. We've seen the definition of fold left, which is good. Now let's look at fold right. Let's look at the definition of list dot fold right. So similar concept, it takes a function, but it takes a list as the second argument and then the accumulator and returns the accumulator, right. So let's in this example, or maybe we do the same example that we did with fold left, let's do it with fold right, right. How does it look like? Fold right takes a function, takes the list 1, 2, 3 and then the accumulator. So if I run this, of course I'll get the same result, but then the question is, why do we have fold left and fold right? Why do we have like two different functions? Why is it useful? So the best example or documentation, that of course there are many documentation tutorials you'll find online. I think this is one given by Lexi Lambda. This was quite interesting, which I came across recently. Let me paste this link also on the chat. So I think whatever I explained here is elaborated a bit more. So if you see the fold left here, see how it expands here, 0 plus 1, then the result plus 2, plus 3, plus 4 and so on. So you have this left open parenthesis, right, accumulating on the left, and this is the more detailed computation that you see here. And similarly for fold right, you have the parenthesis, the computation starts from the right. Now with a fold left operation, you only need the first element, right? In the case of fold right, you have to traverse the list all the way to the end. Now this is a small example, so you can traverse 1, 2, 3, 4, right? If it's a big list, say millions of values, then it will take time, right? But there are operators which are right associative. So in those cases, fold R makes a lot of sense. So I would definitely recommend reading this one. So those are the fold left and fold right examples. Let's continue and write the map function here. So we say let map fl is fold right takes a function and a list and the default value of the accumulator. What the function does, just applies the function to E. Let's check that is good. Okay, the definition looks fine. And but one important thing again with fold left, you have to be careful is that in the case of the at operator, let's say I do concat of L list dot fold left, and we've seen this operator before. We have an empty list and the list itself. So when you're adding like bigger list on the right to the left, it can be very compute intensive. So there's a good page here on comparing the basic OCaml data structures. There's a link given here which talks about the cost of operations for some of the list operations. Right? So we have, for adding an element is order of 1, which is the constant operator. The length function is order of n, and so on. So again, remember this one. Finding an element is order of n. But lists are good for pattern matching and I/O. Right? That's the use case here. So there are some more examples here on implementing the length, reverse and split functions using the fold left and fold right functions. Let's try those. Let me clear this, clear the output. So I said give a new definition of length. L is list dot fold left takes a function which just increments the value by 1. We initial the length of the list is 0, and then we pass the list. Let's run it. This little definition looks good. Reverse of list, this list dot fold left takes a function. Initial is empty list, and then we pass the list. What does the function do? Takes AE and it just reverses the tail with the head. Okay, that definition is fine. And then example of split a list, we have list dot fold right. So don't be afraid of the bigger expressions. The way to think about them is to break it down, understanding the actual type definitions, and then you write them like this, right? And then you can understand what each does, right? And what the function does for x and y tuple, x's and ys, reading pattern matching here. I am just going to create this new tuple here. Okay. Right, definitions looks fine. Right, so let's move on to lists and tail recursion. So we have seen the example for length, right? So how does this actually look in terms of the evaluation, right? When I say length of 1, 2, 3 list, it's actually 1 plus length of 2, 3. So there's an open parenthesis here. And again, this length of 2 plus 3 becomes 1 plus length of 3. And then length of 3 becomes 1 plus length of empty list. Length of empty list becomes 0, then you add the 1, add the result, and then finally we end up with the value 3, right? So that's just the evaluation for you to understand how the computation works. Now for longer list, this may actually overflow the stack. So what we want to do is we always want to write a function with the accumulator, like the fold left, so that it doesn't overflow the memory. So let's take this example of rec length, which is a recursive definition of length, with an accumulator L, and then we match L with an empty list. I just return the accumulator, or if there is a list, I don't care about the head because I am counting it as 1. I just call length again with the accumulator value plus 1, and then invoke length with the tail of the list, right? So the definition looks fine. So I can now say let L is equal to length. I pass the min int value of the length of a list, which is 0, of course. We say 1 here, and then I pass the list, and when I run this, I get the result 3. Okay. So the example here, the stack space size is constant, right? We're not growing to higher memory size. So that's explained here. For every computation, you see it's all actually constant. So this is actually called a tail recursive function, because at the tail we are again calling the recursive function, and you have constant space usage. Now sometimes you'll see in a lot of OCaml code that people actually write these kind of helper functions. So I have something like length inner, where you want to define the same function, and then you want to add a helper function that initializes the default values. Let me check this is fine, okay. And then we define, say, let length L as, you call this length inner with 0 and L. Right, so you're starting with the 0 list size, and then you're calling the function. Or you can also do it in one function. I mostly like these nice compact functions which are like easy to read, easy to maintain and test. But I'll just for the sake of example, let me also try this function. But also you'll see this kind of let in syntax a lot in OCaml projects code. So match L with, if it's an empty list, return the accumulator value, and if there is a list, you just call length inner, just add 1 to the accumulator and return the tail of the list. In I want to call length inner with 0, 1. Okay. 0 and L, not 1. Okay. Yeah, so definition looks fine. So this concludes the list module. So I will make the recording available on the YouTube channel. So I would like you to try this. Watch the video, keep the documentation page, keep the playground active, and then you can try the examples. I've pushed all of these notes and the examples on my Twitch repo. So please feel free to use this as a reference. I mean, you have to read the OCaml or documentation page as well. So I'd like you to read it and then try the examples on the playground, and feel free to reach out if you have any specific questions. Right? And this documentation on fold left and folder is quite nice. I would recommend that you read this. So this Sunday I may not be streaming. I think I'll try to stream on Saturday. We'll do an Emacs session on Saturday, maybe in the evening perhaps. But with this we complete the list module. I want to do maybe loops and recursions next. Let's do that. And so far we have covered the tour of OCaml. We have covered the basic data types and pattern matching. We have covered values and functions. We have completed the list module. Right? We'll do the loops and recursions, and then I will actually teach you to install OCaml using OPAM switch, and we'll do it from the terminal. So that will be a good point to switch over from the playground as you learn more of OCaml. Right. So let me stop the recording here, and let's see who's streaming and we can rate them.